should we? Everyone can see this. Everyone can see this.
Yes, sir.
Okay. So let's start with our today's lecture. Let me start the recording. So, Bismillah Rahman Rahim. Let's start with our today's lecture. At present, there are 19 students in the class, and we are going to start the plane stress transformation. And our today's topic is Mohr's circle. So, in our earlier lectures, we have derived the equations for the computation of transformation of normal stresses, that is sigma x dash, which is equal to sigma x plus sigma y over 2 plus sigma x minus sigma y over 2 cos 2 theta plus tau xy sine 2 theta. Then we have also derived the equation for the normal stresses, transform normal stresses about y dash x's, that is sigma y dash is equal to sigma x plus sigma y over 2 minus sigma x minus sigma y over 2 cos 2 theta minus tau xy sine 2 theta. And the shear stress transform shear stress equation we have developed, tau x dash y dash is equal to minus sigma x minus sigma y over 2 sine 2 theta plus tau xy cos 2 theta. These were our three main equations which we have derived for the computation of transform normal and shear stresses. Then we have derived the equation for the computation of the principal planes. Principal planes are over those planes over which maximum magnitude of normal stresses will occur. Means the largest positive will be over major principal stress, and largest negative, that will be over minor principal stress. So the fourth equation which we derived, that was for the computation of the principal planes, that is tan 2 theta p is equal to 2 tau xy over sigma x minus sigma y. Then we derive the equation for the major principal stress and minor principal stress. So that was sigma x plus sigma y over 2 plus minus the root sigma x minus sigma y over 2 squared plus tau xy squared. The sixth equation which we derived, that was for the computation of the shear planes. One more thing before we proceed further, that we have said that over the principal planes, shear stresses will be 0. Over the principal planes, shear stress will be 0. So then we have derived the equation for the computation of the orientation of the shear planes. Tan 2 theta s is equal to minus sigma x minus sigma y over 2 tau xy. And this we have said that tan 2 theta p and tan 2 theta s, they are negative reciprocal of one another. Then we have derived the equation for the computation of the maximum in plane shear stress, that is tau maximum is equal to under root sigma x minus sigma y over 2 square plus tau xy square. And then the last thing which derived, that was the average stress, average normal stress sigma x plus sigma y over 2. And then we have solved some numericals for the computation of the transform normal and shear stresses. Then principal planes, principal stresses, computation of the orientation of the shear planes and shear stresses. So all these things we have derived and we have solved with the equations. Now all that what we have done earlier, we have used the equations for the computation of transform normal stresses and shear stresses, principal stresses and the shear stresses. Now, maximum shear stresses. Now, the same thing we can do with the Mohr circle. Mohr circle is a graphical solution. Graphical solution means that we have to draw a circle, and from that circle we will get all the stuff we need, like orientation of the principal planes, orientation of the shear planes, magnitude of the principal stresses, magnitude of the shear stresses. So Mohr circle. So we are going to study Mohr circle for plane stress. Over plane stress condition is biaxial stress state, biaxial stress state, and we have studied earlier that in biaxial stress state there will be two normal stresses and one shear stress. Two normal stresses are sigma x and sigma y, and the shear stress is tau xy. So we will show in this section how to apply the equations for plane stress transformation using a graphical solution that will be more convenient to use and easy to execute. Furthermore, this approach will allow us to visualize. Visualize means that earlier we have said that this difference between theta p1 and theta p2 is 90 degrees, theta s1 and theta s2 is 90 degrees, theta p1 and theta p2 can visualize and you can see with the help of the Mohr circle. So furthermore, this approach will allow us to visualize how the normal and the shear stress components x dash and tau x dash y dash vary. Now, guys, one thing to be noted, just like in over xy plane, each point has x coordinate and y coordinate. Okay, so each point has basically distinct x and y coordinate. Now, similarly here, for every point on the Mohr circle. Mohr circle is the circle, so there are, you can say the theta can vary for up to 360 degrees. So for each theta value, you will have a set of specific normal and shear stress components. So how the normal and the shear stress components sigma x dash and tau x dash y dash vary as the plane on which they act is oriented in different directions. So when we say different directions, that means different theta values. So for different theta values, you will get what you say a different pair of sigma x dash and tau x dash. Now, how the Mohr circle is drawn. So these were the two main equations. So this is basically equation 1 and equation 3, which we have derived earlier. So in this equation, what they have done earlier, we have said that sigma x dash, earlier this coefficient was on the right hand side. So we have said sigma x dash is equal to sigma x plus sigma y over 2 plus sigma x minus sigma y over 2 cos 2 theta plus tau xy sine 2 theta. Okay, and over equation 3 was tau x dash y dash is equal to minus sigma x minus sigma y over 2 sine 2 theta theta. Okay, now in these equations, what we have done, we have moved the coefficients in which there is no theta component. So we have moved the coefficients in which there is no theta component on the left hand side, and the coefficients with which there is theta value. So those coefficients have been moved towards the right hand side. So sigma x dash minus sigma x plus sigma y over 2 is equal to sigma x minus sigma y over 2 cos 2 theta plus tau xy sine 2 theta. And tau x dash y dash is equal to minus sigma x minus sigma y over 2 sine 2 theta plus tau xy cos 2 theta. So now the parameter theta from these two equations can be eliminated. How it can be eliminated? If we take the square of the components, like the square of this component, square of this component, then square of this component, and then square of this component. ठीक है जी? So the parameter theta can be eliminated by squaring each equation and adding the equations together. ठीक है जी? So guys, later on when you will do this, please do this calculation as well. Like take the square of these parts, take the square of the coefficients, then add these two equations together. The resultant equation that we will get is this one, and the resultant equation is sigma x dash minus sigma x plus sigma y over 2 square. This one plus tau x dash y dash square is equal to, now the square, and after adding of these two it will become sigma x minus sigma y over 2 square plus tau x y square. ठीक है जी? So now if you see this sigma x plus sigma y over 2 is basically your average normal stress. So sigma x plus sigma y over 2 is average stress. ठीक है जी? So we can replace sigma x plus sigma y over 2 with average normal stress. Then can you recall what is this sigma x minus sigma y over 2 square plus tau x y square? Can you recall what is this? Anyone? Anyone? No one? If no one, then I can let you know. See this. This is the resultant. Tau x y sigma x minus sigma y over 2. So resultant of this sigma x minus sigma y over 2 square plus tau x y square. So resultant is under root sigma x minus sigma y over 2 square plus tau xy square. Now in the equation which we have got, you do not have under root, you just have sigma x minus sigma y over 2 square plus tau xy square. Now let me come back to this. So the equation we have is sigma x minus sigma y over 2 square plus tau xy square. So it means it is the square of the resultant. Now this one we are going to replace it with average stress. This one we are going to replace with the resultant R. Now for any specific problem, means to say for any given theta value, for any specific problem, normal this plane stress state, this sigma x, sigma y, and tau xy. These two normal stresses and the shear stress, these three stresses for any specific problem, normal stress sigma x, sigma y, and the shear stress tau xy, these are over known constants. These are over known constants. Thus, in the above equation, it can be written in a more compact form: sigma x dash minus sigma average square of this plus tau x dash y dash square is equal to r square. Everyone clear that how we got this equation? Sigma x dash minus sigma average square plus tau x dash y dash square is equal to r square. Everyone clear with this equation?
Yes, sir.
Okay, now average stress is sigma x plus sigma y over 2, and the radius or the resultant you can say under root sigma x minus sigma y over 2 square plus tau xy square. Now this is the point, this is the basic equation of the Mohr circle, this one which has been numbered as equation 11. ठीक है जी. So now we will start over Mohr circle, that how we can establish over Mohr circle. Now to establish Mohr circle, first of all we have to draw the axis over horizontal axis. Over horizontal axis is over normal stress axis. ठीक है जी. Horizontal axis is normal stress axis, and over vertical axis is over shear stress axis. So I repeat, horizontal is normal stress axis, vertical is shear stress, vertical is shear stress axis. Now another thing important is that normal stresses, they are positive towards right. ठीक है जी. So normal stress is sigma normal stress is positive to the right. So towards the right normal stress is positive, towards the left normal stress is negative. ठीक है जी. So towards the right normal stress is positive, towards the left normal stress is negative. Now comes the important point, shear stress. Shear stress is considered positive downwards. This shear stress, it will be considered positive downwards. Shear stress is positive downwards and negative upwards. Shear stress is positive downwards and negative upwards. So is this clear? Is this clear that the shear stress is positive downwards, normal stress is positive towards the right? ठीक है जी? No. You have your normal stress sigma x, sigma y, and the shear stress tau xy to start with the circle. So first step is you will calculate the average stress. Average stress is sigma average is equal to sigma x plus sigma y over 2. Okay, you will calculate the average stress. Now this point C, the center point of the Mohr circle, center point of the Mohr circle, it has coordinates. So the Mohr circle, the center of the Mohr circle has the coordinates sigma average and 0. Why 0? Because it is lying on the horizontal axis and the shear stress value on the horizontal axis is 0. So the center point of the Mohr circle has the coordinates average normal stress, ठीक है जी, and 0. So first point is you are going to locate this center point of the Mohr circle. Center xy squared. So after this, you can place your compass at the center point, okay, and open up equal radius of the circle and draw the circle. Okay, ji? And now we are going to find out what is over this point P. What is this point P? So each point on Mohr circle represents the two stress components. Okay? Each point on the Mohr circle, as you can see, that each point on the Mohr circle will have a specific point of shear stress. So each point on the Mohr circle represents the two stress components, that is sigma x dash and tau x dash y dash, acting on the side of the element defined by the x dash axis. Now case one is this is my x-axis, this is y-axis, so this is sigma x, this is sigma y, this is my tau xy. Now case one is that our element is oriented, means to say that x dash axis is oriented at an angle theta which is equal to 0 degrees. Okay, so x dash axis is oriented at an angle 0 degrees with reference to x axis. So which means that our x dash axis is coincident with the x axis. Okay, similarly y axis is same as the y dash axis. Okay, so now over normal stress sigma x, that will be now the same as sigma x dash. So sigma x dash value will be same as sigma x. Sigma y, its value will be sigma y dash, its value will be same as sigma y, and tau x dash y dash will be same as tau xy. So now each point on the Mohr circle represents the two stress components, sigma x dash and tau x dash y dash, acting on the side of the element defined by the x dash axis. So when the axis is in a specific direction theta, for example, when x dash is coincident with the x axis, means x axis and x dash axis, they are same, coincident. So when x dash axis is coincident with the x axis, then theta is 0. So when theta will be 0, so it means my sigma x dash will be same as sigma x. It will be same as sigma x, and tau x dash y dash will be same as tau x y. Everyone clear with this point? So this is our case 1 when x dash axis is coincident with x axis. ठीक है जी? Is this fine? Okay. Now our second case. So now this point where theta is 0 and sigma x dash is equal to sigma x, tau x dash y dash is equal to tau xy. So this point is referred to us as our reference point, and it is designated as A, reference point A, and its coordinate will be the same as sigma x and tau x y. So that's why this point is our reference point A. ठीक है जी, this is my reference point, and you can see that this point is downwards. Why downwards? Because shear stress is positive downwards and normal stress, as we know, is positive towards the right. So shear stress is positive downwards. So this point is my reference point. So this point will be my reference point and it is designated as A. So C to A, it is your resultant C2A is over resultant. ठीक है जी, this is my reference point. Is everyone clear with this point?
Yes, sir.
No. So this was case 1 when theta was 0. Now case 2, theta is 90 degrees counterclockwise. Now it means that the element, this element x y axis, ठीक है, sigma x tau xy sigma y. In this case, x dash axis is oriented 90 degrees with reference to x axis. So I repeat, in this case, over theta is 90 degrees counterclockwise, means that x dash axis is oriented at 90 degrees counterclockwise with reference to x axis. So now what will happen? This axis will become x dash axis, so y axis will become x dash axis, and x sorry and this x axis will become my y dash axis. ठीक है जी, I repeat, when I will my element will rotate by 90 degrees counterclockwise, then my element will rotate 90 degrees counterclockwise. ठीक है जी, then my y axis will become x dash axis and x axis will become my y dash axis. So now consider rotating the x dash axis 90 degrees counterclockwise. Now consider rotating the x dash axis 90 degrees counterclockwise. Then sigma x dash will be about this axis. So sigma x dash will become same as sigma y. Sigma x dash will become equal to sigma y. Is this point clear? Sigma x dash will become equal to sigma y and tau x dash y dash. So tau x dash y dash, when it will be rotated 90 degrees, you can see it is pointing downwards now, shear stress. So tau x dash y dash will become minus tau x y. So when you will consider rotating the x dash axis 90 degrees counterclockwise, then sigma x dash will become equal to sigma y and tau x dash y dash will become equal to minus tau x y. ठीक है जी. Now these values, now the coordinates sigma y, the coordinates of the point G will be sigma y and minus tau xy. These values are the coordinates of the point G on the circle. Now point to be noted here that on the element, the axis is rotated, x axis is rotated by 90 degrees counterclockwise. ठीक है जी, and after rotating 90 degrees counterclockwise, we have seen that sigma x dash will become equal to sigma y and over tau x dash y dash will become minus tau x y. And the coordinate of the point G are sigma y and minus tau xy on the Mohr circle. So let's represent these stresses on the Mohr circle. So now you can see we have said that the shear stress is negative upwards. So shear stress is negative upwards. So minus tau xy, and the normal stress is sigma y. Normal stress is sigma y. So the coordinates of the point G are sigma y and minus tau xy. Now the point to be noted here that this is over reference point A and this is over rotated point G. They are 180 degrees apart. You can see 2 theta. 2 theta is 180 degrees apart. ठीक है जी, you can see this angle is 2 theta 180 degrees, whereas on the element you have rotated On the element, you have rotated it by theta 90 degrees counterclockwise, and here the rotation is 2 theta, means the twice of this. The rotation on the Mohr circle is 2 times of the rotation on the element in the same direction, 180 degrees counterclockwise. So always remember, the second important point about this Mohr circle is that rotation on the element will be theta, and the rotation on the Mohr circle for the same rotation will be 2 theta. 2 theta. So this is my point G, and you can see now the difference between point A and point G is 180 degrees. So rotation on the element will be twice here. On the Mohr circle, it will be rotation will be twice of the rotation on the element. Now another thing we can see this the average stress. So you can see this point sigma y minus tau xy. This point sigma x tau xy. So tau xy sigma y. So this point is my average stress. ठीक है जी, sigma x plus sigma y over 2 average stress. So is this point clear? This that the theta on the Mohr circle will be twice of the theta on the element. If this point is clear, please let me know. If you have any question, please let me know. So the point G, sigma y minus tau xy on the Mohr circle, hence the radial line. Radial line is this one, CG. This radial line CG is 180 degrees counterclockwise. You can see this, they are representing CA is your reference line, and with this reference line CA, you have rotation.
Sir, please repeat.
Your reference line is this CA. So with reference to this CA, you can see the rotation is 2 theta, that is 180 degrees. Hence the radial line CG, this CG is 180 degrees counterclockwise. You can see this line CG is 180 degrees counterclockwise from the reference line CA. In other words, rotation theta of the x dash axis on the element. So you can see here x rotation of x to x dash axis is theta, which is equal to 90 degrees. In other words, a rotation theta of the x dash axis on the element will correspond to a rotation of 2 theta. So you can see this rotation on the Mohr circle is 2 theta. Okay, hence, in other words, a rotation theta of the x dash axis on the element will correspond to a rotation 2 theta on the Mohr circle in the same direction. In the same direction. ठीक है जी? Is this point clear? Is this point clear? So once constructed, Mohr circle can be used to determine the principal stresses, maximum in-plane shear stresses, and associated average normal stress or the stress on any arbitrary plane. So we have said earlier that our principal planes are the planes over which shear stress will be 0. So basically it means our principal planes will be this horizontal line is my principal plane, and where the principal where the Mohr circle cut the principal planes, those points will be your major principal stresses and minor principal stresses. Then is this point clear? We have said that over the principal planes, we have said that over the principal planes, shear stress will be 0. So you can see shear stress over this. and where your Mohr circle cuts the horizontal axis, ठीक है जी, those your larger value will be major principal stress, smaller value will be your minor principal stress. Similarly, we can calculate the maximum value of the shear stress. So maximum value of the shear stress will be here, because shear stresses, they are positive downwards. So maximum in plane shear stress, tau maximum will be at this point. And we can also get the orientation of the shear planes with reference to this what you say reference plane. So moving from the reference plane in this direction, you can get the orientation of the shear planes. Moving from the reference plane CA towards this principal planes, you will get the orientation of principal planes. So let's guys, if you have the book, if you have the book, then kindly open up the book and I will draw the figure, ठीक है जी, so that all these points are clear to you. If you have the book, please open up the book, page 482, and open up this procedure. What I will do, I will open up this what you say whiteboard, and over the whiteboard, step by step, I will draw these points, okay, to construct the circle, to determine the principal stresses, to determine the principal planes, to determine the maximum in plane shear stresses, to determine the orientation of the shear planes, and then if we want to determine any arbitrary plane. Guys, these are standard definitions. This is your standard designation. A is your reference plane or reference point. Okay. C is your center point. Fine. B and D. These are my principal stresses. B is major principal stress. D is my minor principal stress. Then there is E. This is the stress. So now please open our book, and meanwhile I will draw points on whiteboard. It's downloading, so it's just taking a moment. Okay, let's start with the procedure. So if you see this, first step is we have to draw the Mohr circle, and the first step in the procedure is we have to establish the coordinate system. We have established the following coordinate system, in which we have said that that over horizontal axis represents the normal stress, ठीक है जी, over horizontal axis represents the normal stress, and over y-axis represents the shear stress. Then we have said that normal stresses, they are positive towards the right, and shear stresses, they are positive downwards. So this is over what you say, a standard coordinate system. ठीक है जी, and the sign convention is that shear stress is positive downwards and normal stress is positive towards the right. ठीक है जी. Now next thing I want to show you is that this is your plane element. This is your plane element. This is sigma y. This is sigma y. This is sigma x. ठीक है जी. And this is your shear stress. Now, once you have established the coordinate system, the first thing is you need to establish the coordinates of point C. So, point C is your center point of the Mohr circle, and the coordinates we have said of the Mohr circle, center point of the Mohr circle has the coordinate sigma average and 0. So average stress is sigma x plus sigma y over 2. So if I draw the Mohr circle, there's one thing to be noted about the Mohr circle, that the scale on both x-axis and y-axis must be same. Scale on the x-axis and the y-axis, it must be same. Let's say this each tick represents 20 megapascals. ठीक है. So let's mark the point C. Let's say this is my center point. Center point. I will refer this center point as C. ठीक है जी. Then after that, point C, I have to locate my reference point A. So point A is my reference point. ठीक है जी. Point A is my reference point, and point A has the coordinates sigma x sigma x and tau x y. रेफरेंस पॉइंट हमारा क्या था? रेफरेंस पॉइंट was, if you recall, we have said that the reference point is your x-axis and over x dash axis, they are coincident. And similarly here, y-axis and y dash axis, they will be coincident. So our reference point has the coordinate sigma x tau x y. ठीक है जी. Let's say tau x y is positive, so definitely it will be downward. So let's say I mark this point somewhere here. So this is your reference point A. So now what you have to do, you have to connect these two points C to A. This is basically now over reference plane. This is over resultant. ठीक है जी. You can also calculate the magnitude of the resultant, which was resultant. कैसे calculate करना था जी? Sigma x minus sigma y over 2 square plus tau x y. ठीक है जी. So you can also calculate the resultant like this. ठीक है जी. Or you can, using the trigonometric formula, you can calculate the resultant. Is this point clear? Is this point clear?
Yes, sir.
Okay, now we will draw the circle. ठीक है जी. So this is so let's draw the circle. So this is over Mohr circle. So how can you draw it? Once you have marked the center point, and you have the reference point A, open up the compass equal to this, place it at C and draw the Mohr circle. So everyone has drawn the Mohr circle up to this point. So now first step was we have established the coordinate system, then we have calculated the average stress, we have located the point C, which is the center of the Mohr circle, then we have determined what you say a reference point A sigma x tau x y, so that point we have located, then we have calculated the radius, and then we have drawn the circle. ठीक है जी. So now over stresses, I'm reading from the book now. The principal stresses sigma 1 and sigma 2. Sigma 1 will always be greater than sigma 2. Remember this. Major principal stress is always designated as sigma 1 and minor principal stress is always designated as sigma 2. So these are now basically the coordinates of the point. This point, major principal stress, it is designated as B. This is minor principal stress, this is designated as D. Major principal stress is designated as sigma 1 and represented by point B. Minor principal stress represented by sigma 2 and on the Mohr circle designated by point D. So sigma 1 and sigma 2, these are the coordinates of the points where the Mohr circle intersects the horizontal axis, and over this horizontal axis shear stress is 0. Over this horizontal axis shear stress is 0. Is this point clear? Is this point clear? If you have any question, ask me. If it is clear, then we will proceed further. Okay. Now, next thing is, this is our reference plane, CA. C was the center point of the Mohr circle, A is our reference point. So CA is my reference plane. A is my reference point and CA is my reference plane. CA is my reference plane. ठीक है जी. Now over major principal stresses, they have acted over this plane. ठीक है जी. CB. So CB. So moving from reference plane CA, towards this line CB, principal plane over which our major principal stresses sigma 1 is acting. ठीक है जी. This is my 2 theta P1. This is my 2 theta P1. This is my 2 theta P1. ठीक है जी. So moving from the reference plane, the principal stresses acts on the planes which are defined by angles 2 theta P1 and 2 theta P2. In a short while, I will mark 2 theta P2 as well. Represented, ठीक है जी, and these are measured from the radial line CA to CB. This is your 2 theta P1. Now sigma 2, the minor principal stress acts over this plane CD. ठीक है जी, this acts on over this plane CD. So this plane is this CD. ठीक है जी, CD. So moving from the reference line or reference plane CA in the counterclockwise direction towards the reference towards the plane CD. ठीक है जी, so this will represent 2 theta P2. This will represent 2 theta P2. 2 theta P2. And one more thing we have said earlier, that the difference between 2 theta P1 and 2 theta P2 is कितना है जी?
180 degree.
180 degrees. The difference between 2 theta P1 ठीक है जी, and over here you can write sigma 1 is always greater than sigma 2. ठीक है जी, so now you can also visually observe that the difference between 2 theta P1 and 2 theta P2 is 180 degrees. ठीक है जी, now using trigonometry you can calculate this angle 2 theta P1. ठीक है जी, using trigonometry you can calculate this angle 2 theta P1. ठीक है जी, this is my radius and this, if I draw this perpendicular, I can calculate this angle, and 2 theta P2 will simply be 180 degrees plus 2 theta P1. ठीक है जी, another point to be noted that on this element, this is your element, this is your Mohr circle. On the element, ठीक है जी, theta P1 and theta P2 they will be represented by 90 degrees apart. ठीक है जी, theta P1 and theta P2 on the element they will be 90 degrees apart, whereas 2 theta P1 and 2 theta P2 on the Mohr circle they will be 180 degrees apart. ठीक है, and remember one thing, that the rotation will be the same. Whatever is the direction of the rotation on the element, the same will be the rotation of the direction on the Mohr circle. On the element, rotation is counterclockwise. So similarly, we are assuming that the rotation on the Mohr circle is counterclockwise, which is considered positive. ठीक है जी, which is considered positive. So this was about principal stresses and the principal planes. So you can see Mohr circle is so simple. I have got my principal stresses. I have also got my orientation of the principal planes. Now I have to calculate the shear planes. ठीक है जी. So how we will calculate the shear planes? We have said that the maximum shear, we have said that the maximum shear, ठीक है जी, will be here. This is the maximum shear, this is the minimum value of the shear, because shear stress is negative upwards and positive downwards. So this one, so this point is represented as over point E. ठीक है जी, and this point is represented by point F. ठीक है जी. Now we have said that the shear stress is positive downward. So maximum value of the shear stress we can get it from here. So this point we will simply read it from this axis, and this point will be over maximum shear stress. ठीक है जी, and this point will be minimum shear stresses. ठीक है जी, so now you can directly get your maximum shear stress point E, ठीक है, from the Mohr circle. And another point is that over this shear plane, you have maximum shear stress, you have minimum shear stress, and you also see that the average normal stress is also acting over this plane. ठीक है जी, so my average normal stress is also acting over the shear planes, ठीक है जी. Is this point clear? If you have guys any question, please ask me. Do not hesitate. If you have any question, ask me now. No question? Okay, now next thing is we have to let me select this one. So next thing is, once I have determined the average normal stress, maximum shear stress, maximum in-plane shear stress as the coordinates of the point E and F on the Mohr circle, next thing is I have to determine the orientation of the shear planes. Now orientation of the shear planes is, this is over reference plane CA. So moving from our reference plane CA, ठीक है जी, towards CE. So moving from reference plane CA towards CE, this represents my orientation of the shear plane. ठीक है जी, 2 theta S1, 2 theta S1. Is this point clear? Moving from the reference plane CA towards the reference plane CE. So this is my orientation of the shear planes, 2 theta S1. Is this clear? Is this point clear? If this is clear, then next is we need to determine the orientation of 2 theta S2. And again, as we have said earlier, that the difference between 2 theta S1 and 2 theta S2 will be 180 degrees. ठीक है जी, it will be 180 degrees. So for the reference plane CA, moving from the reference plane CA in the same direction towards CF, so this will give me 2 theta. This will give me 2 theta S2, 2 theta S2. Fine. Is this point clear? So theta S1 and theta S2 gives the orientation of the plane, ठीक है जी, and this will be represented by angles 2 theta S1 and 2 theta S2, and these are measured from reference plane CA towards CE and from reference plane CA towards CF. So this will give me my orientation of the shear planes, theta S1 and 2 theta S2. Is this point clear? If you have any query, please ask me now. If you have any query, please ask me now. Okay, then next thing is that just like equations we have, just like equations, we were given that, okay, at theta 30 degrees, calculate the transform, normal, and shear stresses. Now, similarly, if you are given such thing that calculate what you say transform, normal, and the shear stresses on the element which is rotated 30 degrees counterclockwise. Now, we have said earlier that in this case, each point on the Mohr circle has specific value of the normal and the shear stress. So now if we are given a question and that we have to calculate normal and shear stresses of the element which is 30 degrees counterclockwise. So with reference to this plane CA, which is our reference plane, we will move to theta 2 times 30, 60 degrees from the reference plane CA, and we will draw the line. And where that line, 60 degrees line, will bisect the Mohr circle, that point will be basically over point transformed what you say point where we want to get over transform normal stress and transform shear stress. So now guys, we will do the numerical, and in the numerical we will do all this with some particular values. If you have any question, please ask me now. If you have any question, please ask me now. Jawad, is this clear?
Yes, sir.
Yes, sir. Okay. Now, now the same question which we have earlier solved with the help of equations. Okay, the same question which we have solved with the help of equations. This question. Just a moment. ये वाला क्वेश्चन किया था ना कि एग्जांपल 9.2 we calculated what you say element oriented 30 degrees. Fine. Now this question, no, sorry, not this question. It was 9.3 which we are going to repeat. This question, yes. So we said represent, you were given sigma y, sigma x, tau xy, and you were asked to calculate the orientation of the principal planes, major principal stresses, minor principal stresses, and similarly you were asked in 9.4 with the same data to calculate the maximum in-plane shear stress, associated average normal stress, and also to calculate the orientation of the shear planes. Now the same question with the same data, we are now going to use the Mohr circle, and using the Mohr circle, we will draw this and we will calculate over shear stresses, principal stresses, orientation of the principal planes, orientation of the shear planes. So let's start the numerical. So numerical will be 9.8 and 9.9. So numerical will be example will be 9.8 and 9.9. So the state of the plane stress is given to us 90 megapascal sigma y, shear stress shear stress tau xy 60 megapascals, and this sigma x, it is minus 20 megapascal. So this data is given. The state of the plane stress at a point is shown on the element. The state of the plane stress at a point is shown on the element. ठीक है जी, sigma x minus 20, sigma y 90, shear stress 60 megapascals, and we have to, in 9.8 we have to determine the maximum in plane shear stress. ठीक है जी, and in the second part they are asking the same thing, that we have to calculate what you say the principal stress. With this same question, the principal stresses, shear stresses, orientation of the principal planes, orientation of the shear planes, ठीक है जी, all this we are going to use, we will calculate using this data. So let's start with numeric. And one more thing, so the results which we have is we must get the same results with the Mohr circle. It's not sure whether we are doing it good or not. So let's start with our numeric. So you can write the statement if you like. The state of the plane stress at a point is shown on the element. The state of the plane stress at point is shown on the element. We have to determine the maximum in plane shear stresses, principal stress, orientation of the shear plane state. So all that we are going to do with this in this numerical. Guys, one more thing while the board is loading, in paper as well, in the practice problems which I will give you, we will work in SI units. ठीक है जी, we will not be using FPS. We will be working, in my part, we will be working in SI system. We will be working in, done?
Yes, sir.
Okay, ji. In the question, the data is given to you as sigma y is 90 megapascals. Sigma y is 90 megapascals. Shear stress आपका कितना है जी?
60 megapascal.
60 megapascals positive here. 60 megapascals positive. So sigma x is negative 20 megapascals. So sigma x is minus 20 megapascals. ठीक है जी. So now what we want to do, we want to calculate principal stresses, shear maximum in plane shear stresses. We want to calculate the orientation of the principal planes. We want to calculate the orientation of shear planes. We want to calculate the average normal stress. So let's start. So first point is I have to calculate. ठीक है जी. So the first point is I have to calculate the average stress. ठीक है जी, एवरेज स्ट्रेस कैलकुलेट करें, कितना आता है आपने और मुझे बताएं आंसर. एवरेज स्ट्रेस इज sigma x plus sigma y over 2. Sigma x is -20, sigma y is 90. -20 plus 90 is 70. 70 over 2, 35 megapascals. ठीक है जी. So coordinates of my point C are coordinates of my point C are 35 megapascals and coordinates of point C are 35 megapascal and 0. ठीक है जी. Now please let me know the coordinates of point A. Coordinates of point A are sigma x and y. Sigma x is -20. तो xy आपका कितना है जी? तो xy कितना है? 60. ठीक है जी. Can you guys calculate the resultant? Resultant मुझे बता सकते हैं आप लोग? ये बताएं रिजल्टेंट. दोबारा कैलकुलेट करें रेडियस या रेडियस कितना आ रहा है, दोबारा कैलकुलेट करेंगे. Narak? ठीक है जी. Now we will draw the Mohr circle. The first thing which we need to remember is that the scale. एक सेकंड ये मुझे एक मिनट. The first thing we need to remember is that over scale on both x-axis and y-axis, that needs to be same. ठीक है जी? That needs to be same. So what I am doing, as you know, that vertical axis is shear stress is positive downwards. No, horizontal axis is normal stress is positive rightwards. So I am taking this one black tick equivalent to 20 megapascal. So this is minus 20, minus 40, minus 60, minus 80, minus 20, 40, 60, 80 megapascal, 20, 40, 60, 80, 100, 120, minus 20, minus 40, minus 60. So first is I have to locate my average point. ठीक है जी, हमें अपना एवरेज पॉइंट लोकेट करना है. सो एवरेज पॉइंट इज 35 megapascal average stress and point C coordinates are 35 and 0. So this is 20, this is 40, so 35 will be somewhere here. ठीक है जी, agree with this? Agree? So this is over average stress and the coordinates of the point C. Coordinates of the point C are 35 megapascal and 0. So this is 35 megapascal and on the shear stress it is 0. So this is my point C. Is this point clear? Is this point clear?
Yes, sir.
Next thing is I need to locate my point A. Now in the reference point A, please note it down that sigma x is minus 20 megapascal. So it's minus 60. 60 is tau xy. Now minus normal stress is on the left side. So this is minus 20. 0 minus 20. And shear stress is positive downwards 20, 40, 60. So my point A will be here. ठीक है जी, so this is my reference point A. ठीक है, now I will ठीक है जी, this is my resultant. ठीक है जी, C2A. C2A. Now if you are drawing, it's very simple for you. You just place your compass at C1 up equal to CA and draw. ठीक है जी, so let's the Mohr circle. इसके आप इसको कीजिए. ठीक है जी. Guys, have you drawn the Mohr circle?
Yes, sir.
Okay. Now this is point C. So first thing is we need to figure out the principal stresses. Principal stresses are the points where you can say shear stresses are zero. So you can see where your Mohr circle is bisecting the horizontal axis. Those points are basically your principal stresses. So this one is positive, so this will be larger. So this is sigma 1. I will represent it with point B, and this will be sigma 1. So this is sigma 1. This is negative axis. So it will be here point D, and it will be represented by sigma 2. So can you please let me know the value of sigma 1? Sigma 1 is very simple. This is 35. This is 35. 35 plus the radius. कितना होगा? 116.4 megapascals. $116.4 megapascals. ठीक है जी. सिग्मा 2 35 माइनस रेडियस. 35 माइनस रेडियस तो कितना आता है? ये आंसर बताएं मुझे.
Minus 46.4.
Minus 46.4. So sigma 2 is minus 46.4 megapascals. ठीक है जी. minus 46.4 megapascals. ठीक हो गया. Now I need to calculate the orientation of the what you say principal planes. So moving from the reference CA. So अच्छा, इससे पहले अगर हम जो shear stress है वो भी डिटरमाइन कर लें, वो भी इजी है. So shear stress. जी, shear stress, maximum in plane shear stress क्या होगा जी वैल्यू उसकी? वेरी सिंपल. दिस इज इक्वल टू रेडियस. ये इक्वल टू रेडियस ही आएगा ना? ये इक्वल टू रेडियस ही आएगा. So 0 plus the radius 81.4 megapascals. This is minus 81.4. Yes. So this is 81.4 megapascals. Moreover, you know average stress क्या है जी हमारा? This is also lying on the shear plane. तो average stress आपका कितना है? Average stress आपका कितना है? 35 megapascals. We have already calculated 35 megapascals. ठीक है जी. Now we have to calculate the orientation of the principal planes, orientation of the shear planes. पहले थीटा जी. First we can calculate the orientation of the shear planes. वो ज़्यादा simple है. So moving from the reference plane CA towards the plane CE. ठीक है जी. So this one will give me 2 theta S1. And this is 2 theta S1. This is counterclockwise. So guys, can you please calculate 2 theta S1? Yet you can use simple trigonometry here. Simple trigonometry can be used to calculate 2 theta S1. So please let me know the value of 2 theta S1. जी 21.3 आ रहा है मेरे पास आंसर. Are you guys also getting the same answer? Sorry, 2 theta S 42.6. आपका क्या आंसर आ रहा है? 2 थीटा S1. जी आप पहले कैलकुलेट कर लें. ये होगा यहाँ तक है 35 प्लस 20 55. दिस इज 60. ये पॉइंट ए के कोऑर्डिनेट 16 है तो ये 60 हो गया. तो पहले आप कैलकुलेट करें. tan थीटा इज इक्वल टू 10. बेसिकली इसे 2 थीटा ही रख लेते हैं. tan 2 थीटा इज इक्वल टू 55/60. तो ये आपका आ रहा है एंगल थीटा कितना आता है ये बताएं. ये वाला एंगल कितना आता है? 2 थीटा. जी मरियम.
0.5.
नहीं एंगल की वैल्यू क्या आएगी? tan 2 थीटा इज इक्वल टू 55/60. तो इससे थीटा इन डिग्रीज निकाल लें. वो कितना आता है? टू थीटा ही रखिएगा जो भी आप आंसर है. $42.5 आ गया. आप लोगों का कितना आ रहा है? Theta S1 value with me is 21.3 degrees. ठीक है जी. और if you want to calculate 2 theta S2. So moving from the reference plane CA towards CF. ठीक है जी, तो ये आपके पास आ जाएगा 2 थीटा S2, 2 theta S2, and this time our values we are reporting, they are counterclockwise. They are counterclockwise. ठीक है जी. Now next thing we have to report is the orientation of our principal planes. Orientation of principal planes. So moving from reference plane CA, moving from reference plane CA towards this plane. ठीक है जी, this plane. Moving from reference plane CA to CB, this will give me 2 theta P1, 2 theta P1, 2 theta P1, and moving from the reference plane CA towards CD. ठीक है जी, that will give me 2 theta P2. So guys, can you please calculate the value of 2 theta S1, theta S1 and theta P1? ये दो वैल्यूज कैलकुलेट करें और मुझे बताएं. जी, आप अगर 2 थीटा S1 ऐड कर लें, ठीक है जी, 2 थीटा S1 ये अगर कैलकुलेट कर लें, विच इज कैन बी वेरी सिंपली कैलकुलेटेड. ये जो है आपके पास है 55, here to here is 35 and this is 25 and this is 60. So tan 2 theta आपके पास आ जाएगा 55 over 60. ठीक है जी, ये वैल्यू आपके पास आती है 2 थीटा S1 42.6 degrees, 42.6 degrees, 42.6 degrees, this one. (42.6 degrees). So हाफ हो जाएगा इसका 21.3 degrees. ठीक है जी. So 42.6 degrees और 2 theta P1 कितना होगा? ये 42.6 degrees plus 90, 132.6. 132.6. तो हाफ थीटा P1 कितना होगा? 66.3 degrees. ठीक है जी. So if I draw यहाँ पे on the Mohr circle you have to find 2 theta S1 and 2 theta P1. 2 theta S1 is 42.6 degrees. 2 theta P1 is 132.6. ठीक है जी, 132.6 degrees. ठीक है जी. और जब आप थीटा P1 and थीटा S1 करेंगे, that will be half of 2 theta P1 and half of 2 theta S1. So when I represent it here, ठीक है जी, when I will represent here 2 theta, just a moment please, 2 theta S1 is this one. ठीक है जी, this angle is 21.3 degrees. ठीक है जी. And P1 66.3 degrees. ठीक है जी, and we have said that the difference between theta P1 and theta S1 must be 45 degrees. ये हमने पहले स्टडी भी किया था कि जी difference between the two should be exactly 45 degrees. 45 degrees. Guys, now one more thing I want you to calculate. Let's say you are asked to calculate the transformed normal stresses and transformed shear stresses at an angle 40 degrees counterclockwise. ठीक है जी, आपको हम कहते हैं कि you have sigma x dash. Calculate sigma x dash, tau x dash, y dash, tau x dash, y dash for theta 40 degrees. Theta 40 degrees. ठीक है जी, theta 40 degrees. So it means on the Mohr circle it is 80 degrees counterclockwise. So moving from my reference plane, this is my reference plane CA. So moving from the reference plane 80 degrees. This is 42.6, which we have already calculated. So your this 80 will be somewhere roughly here. You can calculate it exactly with the D, and where it bisects the Mohr circle. ठीक है जी, where it bisects your Mohr circle. ठीक है जी, this point. So where it bisects your Mohr circle, from there you can get your transformed shear and transformed normal stress. ठीक है जी, you can get your transformed shear and transformed normal stress. ठीक है जी, so in this way, at any orientation, at any given orientation, you can calculate the transformed normal and transformed shear stresses. Guys, if you have any question, please ask me now, so that everything must be clear with you. If you have guys any question, please ask me now. Everything is clear, guys? Everything is clear? Jawad, is it clear?
Yes, sir.
Yes. Mariam, is it clear?
Yes, sir.
Okay, if it is clear, then that's it for today. So today we have done the Mohr circle. So you have seen that Mohr circle is much simpler way of calculating. You can see the principal stresses, shear stresses, orientation of the principal plane. Guys, always remember this, your reference plane will be CA. CA will always be my reference plane. So I will always move from reference plane CA towards CB and towards CD to get the orientation of the principal planes. You can also move from this clockwise. Okay, then in the value you have to mention that I am measuring clockwise. Okay, otherwise we assume that we will move in counterclockwise direction because that is positive. Okay, then to get the orientation of the shear planes, I will move from reference plane CA towards the shear plane CE, and then from the reference plane CA towards the shear plane CF to get my orientation of the shear planes. Sigma 1 and sigma 2 are my principal stresses where my Mohr circle bisects the horizontal normal stress axis. Point E is my maximum shear stress, and I will get the maximum shear stress where what you say my point what you say where your shear stress will be maximum, and the shear stress will be maximum downwards. Shear stress is maximum downwards. So point E will give me the maximum shear stress. Is this clear? All clear? If it is all clear, then let me stop the recording and let me download your attendance. Meeting attendance 120. And because आपकी क्लास में आज maximum 29 students आए हैं,